In a world where space and time are intertwined, one man dared to challenge the status quo. His name? Dayton Miller. His weapon of choice, a flute. But not just any flute. This instrument held the power to unleash the ether, a pervasive medium once thought to fill the universe. Miller, a physicist by trade, a musician at heart, discovered a harmonic resonance within the ether. He found that his flute, when played with precision, could manipulate this elusive medium. His melodies, a symphony of science, had the potential to shift the very fabric of reality. However,
Hola, lads and ladettes. We're here live with episode 57 of Aether Cosmology. We're joined today with Dr. Michael Heffron, who's going to be doing a little presentation on the momentum of the Luminiferous Aether. So, Dr. Michael, whenever you're ready, sir, take it away.
Okay. Are my slides on the screen?
Yep. Yes, sir.
Sorry, I can't. I'm going blind. I'm only seeing my slides and can't see anything else. So this presentation, in this presentation, I'm going to discuss how the momentum of the luminiferous ether reduces the fundamental constants of physics. And I've got a few disclaimers. My dissertation committee often complained about my tendency to logically leap over concepts that just seem so obvious to me that I didn't bother explaining my thought process. And then on the other hand, many journal editors reject my paper submissions as being too tutorial. And also in this presentation, certain values may seem to have an excessive number of digits of precision. And the reason for that is my level of precision facilitates the reason. What was that?
Well, that was a hot mic. You can go ahead and continue. Sorry about that.
Okay, so sorry, I'm still pretty novice to Discord, and I'm not used to what goes on here. Anyway, my level of precision makes it easier to compare the stated uncertainty of measurements published by NIST. And NIST is an acronym for the National Institute of Standards and Technology. Probably you all know that, but just to make sure I'm not taking any logical leaps. And those comparisons will be coming up somewhere in the neighborhood of 12 slides from now. There's probably one other disclaimer that should have been here. Is I have two Great Pyrenees dogs who just come and go in the house as they please. And so if you hear some dogs barking, it's probably coming from me.
No worries.
All right. It quickly became... Thanks for understanding. It quickly became obvious to me that there will always be people who criticize your work for some reason. So my secret to success is to try to upset the right people for the right reason. My goal for this particular presentation is to be minimally tutorial, where I'll briefly present obvious concepts solely to ensure that everybody takes that leap with me. And if I happen to advance to the next slide too quickly, please ask me to go back. I'm so familiar with this. If you want to look at a slide longer, I may not anticipate that. Sorry about that. Momentum is the very simple concept of mass times velocity. And momentum is the reason Newton's first law of motion states that every object tends to remain either at rest or in uniform motion until a collision or other external force intervenes. And you probably all know Newton's first law may be better known as the law of inertia by a lot of people. And before exploring momentum in greater detail, it's important to review some basic celestial mechanics. And the reason for that will become obvious quickly. Astronomers and satellite operators use the Greek letter mu to represent a body's standard gravitational parameter. And they calculate that parameter as the universal gravitational constant times the masses of the bodies. They often omit the insignificant mass of small satellites, and also even large rockets are small in comparison to the Earth. This presentation will now begin to explain why big G is not universal and why the masses of the satellites are irrelevant. Sorry, not just the masses of satellites, masses of the bodies in general are irrelevant. And that begins with Kepler's third law, which defines T as the period of the orbit of any given planet. C is a constant that applies throughout the solar system, and R is the mean radius of orbit of the semi-major axis of an elliptical orbit. Newton very quickly deduced that the inverse of Kepler's constant is still constant, and he based a lot of his work on that. The next slide is going to very slightly modify Newton's deduction to produce the gravitational parameter for any celestial body or subatomic particle. You'll find this in chapter 5 of my book about the scientific method, which advocates using the ancient Greek letter kappa to express a body's gravitational parameter as the velocity squared times the radius of orbit for any of that body's satellites. And note that the masses of the bodies are irrelevant for this method of finding the gravitational parameter of the orbited body. Here are a few examples. The planets orbiting our sun, velocity squared times the radius of orbit is the sun's constant gravitational parameter. And I copied and pasted this from my book about the scientific method. And in that book, footnote 12 explains that this table only temporarily elevates Pluto back to its former planet status for the purposes of this table. E squared times the radius of orbit for the moons of Jupiter produces a much smaller constant. And this constant is the gravitational parameter for Jupiter. Also notice that Pasiphae, I was worried about, I pronounced that word wrong, Pasiphae, and I've studied how to pronounce it properly, and there's a lot of discussion about what's proper, and so if you don't like my pronunciation, use your own. But anyway, it conforms to Jupiter's gravitational parameter despite the fact that it orbits counter to the direction of Jupiter's rotation, whereas all of the other planets of Jupiter rotate in the same as its direction of rotation. Earth has an even smaller gravitational parameter, and this is known to such great precision due to modern spaceflight technology. The velocity squared of an electron orbiting a proton at the Bohr radius is found by dividing the Hartree energy by the mass of an electron. Therefore, the gravitational parameter of a proton is the velocity squared of that electron times the Bohr radius at which it orbits. And please forgive my inconsistency here. My prior slide used kappa sub p for the gravitational parameter of a proton, whereas this slide spells out the word proton. But the point of this slide is that Newton's gravitational constant is actually the gravitational parameter of the sun divided by its alleged Newtonian mass. That is far smaller than the gravitational constant for a proton, thereby demonstrating that Newton's gravitational constant is not universal. We have now reached the beginning of the promised explanation for why my data seems to be way too precise. From these equations, you'll see that it's possible to use the gravitational constant of a proton to calculate the Hartree energy of an orbiting electron. It is also possible to use Coulomb's constant, but notice that it's just as easy to calculate the energy of the electron using the gravitational parameter of the proton. The green digits here represent a discrepancy between my data and NIST data that is within the bounds of NIST stated uncertainty. And something to notice about these values is all the values are identical regardless of the constants used to calculate the Hartree energy. So the numerator is identical down to the last digit for all of these ways of calculating it. Numerator is the same in all cases, so that's obviously the same. And the result is the same because all the contributing values are the same. What NIST now calls the atomic unit of force was formerly called the electrostatic force acting on an electron orbiting at the Bohr radius of a hydrogen atom. The only difference between the Hartree energy equations and electrostatic force equations is that the Bohr radius is squared to determine the force, whereas it was not squared to determine the energy. So put another way, the Hartree energy is divided by the Bohr radius to determine the electrostatic force. Thus, there is an inconsistency in the data published by NIST. The same source data can't produce 12 digits of accuracy for the Hartree energy and only 9 digits of accuracy for the corresponding electrostatic force. And to clarify that comment, NIST's calculation using their own data for the Hartree energy and the Bohr radius is self-consistent, but is inconsistent with the other methods of calculating that same force using their data. I didn't point this out previously, but my data is based on parameters of the luminiferous ether, and we'll be getting into that really soon. But first, a consequence of the gravitational parameter applied to the orbit of an unobstructed satellite is that a sufficiently low orbit must ultimately reach the speed of light. And that means that the luminiferous radius of any given body is equal to its gravitational parameter divided by the speed of light squared. In other words, there is a black hole at the core of all celestial bodies and all subatomic particles. And this is the density. The density of a spherical black hole must be its mass divided by its volume, where the section symbol I'm using here represents a scalar value required to convert a radius cubed into the volume of a sphere. Using the mass and the luminiferous radius of a proton as a calibration standard, that means the density of black holes must be nearly 18 quadrillion kilograms per cubic meter. My book about the luminiferous ether resulted from asking the question, could that be the density of the luminiferous ether? The topics up to this point were primarily from my book about the scientific method. The remaining topics for this presentation are primarily from my book about the luminiferous ether. Starting from the archaic assumption that the speed of light in ether behaves like the speed of sound in air, refactoring the equation on the left for the speed of sound enabled me to calculate the pressure of the ether from its density times the speed of light squared. Conveniently, NIST defines the speed of light as an exact value, which made it easy to determine whether those were the correct values for the density and pressure of the ether. Notice that these equations highlight the fact that everything we call constant is at best very stable variable. And this is where my journey of discovering the luminiferous ether began. The mass of a black hole is the density of the ether times the luminiferous volume of the black hole. So that's an easy way to determine the mass. Similarly, what Einstein called the relativistic energy of a black hole is the pressure of the ether times the luminiferous volume of the black hole. And he didn't call it the relativistic energy of a black hole. Black holes came later, but this is the equation for what Einstein called relativistic energy. The top equation is the rearranged speed of sound equation used previously to determine the pressure of the ether. So notice that multiplying both sides of the top equation by the volume of a specific black hole results in Einstein's famous equation for converting the mass of that volume into energy. In other words, Einstein's relativistic energy is released by a mass when the ether within its volume stops whirling, and that causes its former mass to scatter away in various directions as energy. As of last year, the total daily energy consumption by the entire population of the world was about 2 quintillion joules. That's 10 to the 18th power. That much energy results from applying ether pressure to a volume about the size of the smallest specks observable by optical microscopes. So Tesla was right. We're just swimming in a sea of energy. It's easy for people to view the attributes in this table as different measurements because each requires its own unique measuring device. But a more thorough examination reveals that these attributes are actually just different ways to view the momentum of ether particles. Just as water molecules in a bucket simultaneously exhibit all of these attributes and many more, so does the ether contained within a volume. It doesn't matter that we don't know whether the ether consists of neutrinos, quantum fluctuations, or something else. Although we don't know the composition of the luminiferous ether, it is clear that it behaves as though it is a superfluid gas that is composed of neutral colliding particles. The surface tension of any given black hole is equal to the pressure of the ether times the luminiferous radius of the black hole, or the density of the ether times the gravitational parameter of the black hole. That means the surface tension of a black hole represents an equilibrium between the density and pressure of the ether. Many different surface tension equations exist depending on the fluids and their shape. What most of these equations seem to have in common is a pressure difference, whereas the pressure on both sides of the interface for black holes is the pressure of the ether. The unique surface tension of black holes seems to result from the equilibrium between density and pressure. And that's why this equation doesn't look like probably any other surface tension equation you've ever seen. Expressed in a different form, it becomes obvious that the surface tension of a black hole divided by the pressure of the ether determines the size of the black hole. And then similarly, the surface tension of a black hole divided by the density of the ether determines the gravitational parameter of the black hole. The elementary charge is the electric charge carried by a single proton. When negative, it is the electric charge carried by a single electron. Currently, NIST defines the elementary charge as an exact value. But originally, the elementary charge was equal to the Faraday constant divided by the Avogadro constant. For ether calculations, it is more convenient to deal with charge squared vacuum permittivity was formerly called the distributed capacitance of free space, or the electric constant. Only when it's reduced to the simplest terms of the ether does it become obvious the electric constant derives from the pressure of the ether. And you see that at the bottom of the far right. Vacuum permittivity, vacuum permeability was formerly called the distributed inductance of free space, or the magnetic constant. Only when reduced to the simplest terms of the ether does it become obvious the magnetic constant derives from the density, from the density of the ether, and you see that on the far right. Here's a side-by-side comparison of the electric and magnetic constants, and in this, the symmetry of those constants is more obvious. In this form, it's also more obvious the relativistic energy of the electron influences electricity, whereas the mass of the electron influences magnetism. And in the blue, there's a little sub-equation where you can see you can interpret me times c squared as the energy of the electron, or you can interpret c squared times the luminiferous radius of the proton as the gravitational parameter of the proton. It may come as a surprise to discover that light behaves like a black hole, with a surface tension equal to the pressure of the ether times the luminiferous radius of light. And that makes more sense when you pause to consider that ether contained between the longitudinal oscillations is not very different from ether contained within a whirling volume. The luminiferous radius of light is equal to the Compton wavelength, or the de Broglie wavelength of an electron traveling at the speed of light. It's true for all black holes. Light itself has a gravitational parameter of its surface tension divided by the density of the ether. That is equal to the velocity of light squared times the radius of orbit, as is also true for all black holes. A question worth asking is, could light be the luminiferous equivalent of a sonic boom? Light waves propagating through the luminiferous ether have a kinematic viscosity equal to the gravitational parameter of light divided by the speed of light. For anyone who may be unfamiliar with kinematic viscosity, that is a fluid's internal resistance to flow under gravitational forces. It is interesting to note that the Planck constant is equal to the mass of an electron times the kinematic viscosity of light as it propagates through the luminiferous ether. That equation expands to emphasize what H times F really means. Multiplying both extremes of that prior equation by frequency reveals how the luminiferous ether impacts the energy absorbed or emitted by an electron. Wavelength of light times the energy absorbed or emitted by an electron has the physical units of force times area. That is a constant that is equal to the mass of an electron times the gravitational parameter of light. What many researchers call a photon actually behaves more like an electron accelerated to the speed of light. And therefore, it makes sense that the fine structure constant is equal to the velocity of an electron in orbit at the Bohr radius divided by the speed of light. And the unique property of the Bohr radius of a hydrogen atom is that it is the only radius where the period of the electron's orbit exactly equals the period of the corresponding 45.56 nanometer wavelength of absorbed or emitted ultraviolet light. And so you'll see that figures prominently in the equations. These next few slides are essential for truly understanding quantum levels. Anyone who wishes to replicate these experiments can use an inexpensive acrylic prism. Hold the prism with the apex up above your eyes and view a well-lit window surrounded by a dark or dimly lit wall or door. You can adjust your viewing angle until you observe a blue fringe just above the top of the window, a cyan fringe at the top of the window, a yellow fringe at the bottom of the window, and a red fringe just below the bottom of the window. Notice that the blue and yellow fringes are wider than the cyan and red fringes. Contrary to what modern physics courses teach, prisms do not refract different colors of light at various angles. They actually refract all the colors at the same angle, but internal to the prism, the prism itself separates that light into red, green, and blue panes. And a later experiment will demonstrate that all the colors actually refract at the same angle. In contrast, the separation of colors is not refraction, but deflection of the blue pane toward the apex and the red pane toward the base, and no deflection at all of the green pane. For viewers who are artists, please note that the colors of light don't mix like colors of pigments. For example, yellow and blue pigments make green, whereas yellow and blue light make white. The white and yellow layers of this slide demonstrate that mixing. With a sufficiently narrow band of light, so a window won't work for this, you'll need to narrow it up a little bit. The color panes separate from each other to produce red, yellow, green, cyan, and blue. And a raindrop or other imperfect prism often mixes these colors to also produce orange, indigo, and violet. All of the colors of light refract at the same angle when they enter a prism. If you look at the gray circle on the left with the apex of your prism pointing up, you will observe that the transition from lighter to darker or darker to lighter separates the colors, just as Johann Wolfgang von Goethe observed over 3 centuries ago. Please pay particular attention to the top of the gray circle on the right. Notice that the blue and cyan fringes at the upper left side of that circle align with the yellow and red fringes at the upper right. So they're not refracting at different angles. Similarly, the yellow and red fringes at the lower left align with the blue and cyan fringes at the lower right. All of those fringes and their alignment demonstrate that the different colors do not refract at different angles. This slide demonstrates that white light consists of only red, green, and blue. When you look at the white and black lines through your prism with its apex pointed right, you can pull the prism back far enough from the page to see the white line completely separate into only red, green, and blue. And then similarly, the black line will separate into only cyan, magenta, and yellow. Notice that the blue is slightly wider, and it's a little hard to see that on this slide, but it's a little wider and it deflects slightly farther from the green than it does from the red. Chapter 7 of my book, The Luminiferous Ether, explains this in great detail. Now observe directly under the green line on the black background is a magenta line on the white background. Magenta is blue plus red. Green is still absent from exactly where the black line was, whereas red and blue panes deflected in opposite directions to fill the place that was black, and that makes the magenta. Green is only absent from the black line where it never was to begin with. Directly above the black line, only an undeflected green line remains where the white line once was. The green and magenta lines are how you know green doesn't deflect at all. Next, observe that directly under the red line on the black background is a cyan line on the white background. Cyan is green plus blue. Red is still absent from where the black line was, but the entire red color pane is now shifted toward the base of the prism. Finally, observe that directly under the blue line on the black background is a yellow line on the white background. Yellow is green plus red. Blue is still absent from where the black line was, but the entire blue color pane is now shifted toward the apex of the prism. The behavior of those black and white lines from the prior slide is critically important for understanding absorption and emission spectra. This slide depicts the visible light portion of the Balmer M equals 2 spectrum hydrogen atom. Spectroscopy's importance to astronomy, many prominent scientists theorized about the meaning of those spectral lines in the late 1800s. From that work, this theory of quantum mechanics was born. Viewers should suspect that something may be amiss with spectroscopy, since many of those spectral colors result from overlapping red, green, and blue. For example, notice how the 6 nanometer cyan line is between the 434 nanometer blue line and the 656 nanometer red line, yet there is no 509 nanometer green line. And cyan is a mixture of blue and green. It is important to ask, how can blue be present and green be absent? This slide is table 8-1 from my Luminiferous Aether book. It depicts a portion of the Balmer M equals 8 series spectrum for the hydrogen atom. This table shows how red, green, and blue mix at the Bohr radius to produce the illusion of other colors and the associated illusion of quantum levels. Since there are only 3 colors of visible light, all of those other colors are figments of our imagination. And consequently, the theoretical quantum levels corresponding to those imaginary colors can only result from mixing red, green, and blue. This equation is a refactor of the Balmer equation, and it emphasizes how the velocity of electrons produces the various spectral lines. And there's a little inset that shows that the base velocity is equal to the velocity of an electron at the Bohr radius divided by the square root of 8. Balmer's equation requires m and n to be integers, and it usually keeps m constant while incrementing n. If alternatively you keep non-integer n equals 7.5 constant and increment m, Balmer's equation describes 3 colors of ultraviolet light, 3 colors of visible light, and 2 colors of infrared light. Focusing on the visible light, m equals 3 produces 434 nanometer blue light, m equals 4 produces 509 nanometer green light, and m equals 5 produces 656 nanometer red light. This equation reveals that the colors of light result from constant velocity increments. Armed with that knowledge, it's possible to use mass times velocity to explore momentum increments, or mass times velocity squared to explore energy increments, or density times velocity squared to explore pressure increments. Refactoring the prior equation provides the quantum energy levels. And as before, only when n equals 7.5 are the energy levels truly quantum multiples of the mass of an electron times the velocity squared of the electron? All of the other energies are mixtures of those quantum levels, just like the imaginary colors of light are mixtures of those quantum levels. So that actually concludes my presentation, and I'm open for questions now.
Well, that was awesome before anyone else is shell-shocked into speaking. That was amazing. Real quick, I think in the beginning you gave 1 second. You gave a constant for the magnetic constant, and I think there was a slot for the electric sorry, hold on. Can you go back to the electric? Was there a slide with just the electric constant before you had the electric and magnetic together?
There was. So let me go back to that. And I'm gonna get back there this way.
Nice,
There we
perfect.
go. I think that's the one you're referring to.
It is, and you were going right into the birth of, I think, the speed of light based on the rate of induction of the vacuum, I think, or something. Is that what happens next?
So actually, I started with the speed of light, and this presentation didn't flow as nicely as possible because when you start thinking about this, you realize there's a lot of interdependence among all of this, and particularly because let me see, I guess back wherever I first, yeah, right here you see, although we call the speed of light constant, and although NIST defines it as exact, is obviously not exact. In my book, I actually say it's a very stable variable because it depends on the pressure of the ether and the density of the ether. And anybody familiar with Boyle's law will realize those are affected by temperature. And I didn't even discuss temperature, but the ether has to have a temperature just like all other gases or all other fluids have temperatures. And so everything in here is assumed on what NIST defines as the constant speed of light. And that's an appropriate thing to do because they defined it as exact specifically so they could base all of their other measurements on its exactness and not have to deal with the fact that previously its value was varying all over the place and they were having a rough time pinning it down. So I'll go back to the electric constant now.
Right. So yeah. So I think you were deducing the same thing, is that the properties of the vacuum, when you're in your case saying the properties of ether, then right, would induce the permittivity and permeability of free space themselves is what's producing that so-called constant. No.
Right. So my premise is that what we call the vacuum is actually incredibly dense ether.
Which is pretty close to what I think we were saying, I think, Alan, which is what we've been throwing around as our basic premise, although you put it much more eloquently with a much better math description behind it.
And I think a lot of people agree directly or indirectly with that premise because you can see even the relativity advocates, basically they're just doing gymnastics to try to deny the ether when everything is shouting at them that the ether determines everything.
And then they're left trying to have a duality of particles and waves, even though it behaves sometimes as this. And then they try to have dualities in their math to explain the same phenomenon you can elegantly explain with the wave equation. No, I feel you.
Exactly. And since the ether is a superfluid gas, obviously it is mass, but it's also waves.
And this is awesome. I'm gonna have to go back and watch it and take notes and do more stuff. I hope now that you're hanging around, we'll be able to ask you questions, because I'm sure I'll be thinking of questions like next week and still.
You'll definitely be able to ask me as many questions as you want. And and in my spare time, I didn't mention this, but in my spare time, I run a dog rescue for Great Pyrenees dogs. Those are the 100-pound plus big white dogs. And so I get pretty busy with that at times. So I'm not always extremely responsive, but I'll always answer questions. So if you ask a question and I don't answer it, it's possible I got so overwhelmed I overlooked it. So you might, after you give me a day or so, you might want to re-ask the question because I might have gotten so busy I missed it.
No worries. Awesome that you say they work with dogs, though. I think my dog likes that.
My dog's usually watching whenever I'm working at the computer, so I don't know why they're not watching me right now.
Well, mine waits for me to speak, and then he tries to get his barks in because he knows that'll irritate me most and make me take him out immediately. He's like, oh, I got it in. Yeah, he's pissed. He's coming.
I've noticed that dogs seem to speak dog language as well as human language, and I've always felt like they're looking at me thinking I'm stupid because I only speak English and not dog, whereas they understand both. And so they probably discovered everything I talked about long ago, and this is boring to them, and that's why they're not here.
That's a super interesting dog philosophy. Does anybody have any questions on the presentation? A lot of people here.
Just the one on you said it's not it's the most stable variable. You were saying that's because the ether should have a temperature, right? Is that what you were saying?
Right. It should have a temperature, and I didn't want to throw Boyle's law into this equation, but it should have a temperature, which means at a minimum the pressure will vary with temperature, but the density will also vary with temperature. So unless they vary proportional to each other, there's going to be. Oh, actually, I think in my book I make a case that they won't vary together. Temperature will change the speed of light. And you can read my book if you're interested in that aspect, but that's like more of a gut feeling and a logical deduction than anything that I can show you math to demonstrate.
Okay. I was just curious. I just never even thought about it, like the temperature of the ether.
Yeah, you can probably tell I way overthink everything, and I normally try to be cautious about what I say, so I don't become too misleading to make it seem like I know something I don't.
You're saying
you're
that
good,
a temperature fluctuation can violate the premise of special relativity. Fantastic. I think I'm down with that.
Exactly. Yeah, I'll go on record for that. I think it's harder to prove, though.
No, I think satellites and GPS would demonstrate a similar inconsistency. So I think we're also on board.
Something that just came to me right after I said that is the cosmic background radiation may indicate it stands to reason in the cosmic background the temperature is a little lower than here, and maybe that's why we have redshift out there. So maybe redshift is not indicative of anything other than a temperature difference.
No, that's amazing. I know how you started with what did you start with? Well, what was your first couple? Oh, you had Kepler's law. You had all of the observations of the sky reduced to the periodicity. You called them constants, but you reduced them to a periodicity, and then you called the big G the gravitational force or something, and then you compared big G to all the other cosmic forces to clearly say it wasn't universal, right?
Exactly, it's not universal, and it's once you understand what it really is. I'll go back there. Once you understand that it's really the gravitational parameter divided by the mass, and in case of Newtonian masses, I think they're all fictional. In the case of subatomic particle masses, there's a little more reason to believe those are accurate, or at least as accurate as we can be. The point is, both of those would vary if either the gravitational parameter varies or the mass varies. And from the equations for both based on the density and pressure of the ether, I don't know if I have both of those together. I don't think I have them both together, but here's the mass. thought I had one with gravitation. Ah, there it is. No, that's not it either. But anyway, so since they're both since both the gravitational parameter and the mass are based on parameters of the ether, it's obvious both of these could be variable. But in any case, they're definitely not the same and they're not universal. So big G is not universal. It depends on the gravitational parameter and the mass of whatever the body is that's being orbited.
Right. It seems like you broke it down to a series of comparative ratios more than anything, and it's always in an equal ratio. So what you've identified between, I think, all the constants is the proportionality of it, and then carrying that proportionality to make deductions. I think this is awesome.
And then for oh, go ahead.
Oh, sorry. I did have a question, but I can wait.
Oh, okay, I don't want to make you wait and forget your question because I can talk about anything anytime.
Go ahead, Liliana.
Oh, first of all, anyone that loves dogs is a good guy in my book. But I'm really, yeah, I'm really intrigued with the two things that you said just recently. And one is that ether has a temperature, and that totally makes sense to me. And as soon as you said that, it clicked a lot of things in my brain. So thank you for that. And then also, I think you mentioned that the only three colors that actually exist are red, blue, and green. And so,
Right.
Is that correct?
Correct.
Yeah.
And I'm going to go ahead to that slide. There we go.
So
And
my
if you
question
get prism and
is,
look at that white line, you'll actually see that.
sorry, please repeat.
If you get a prism and you look at that white line, you'll actually see it separate just that way into red, green, and blue, and nothing in between.
Wow.
It's a little tricky,
So,
which is why I gave all those instructions for how to do it. And those instructions are also repeated in my book. And I saw Alan posted a PDF of the presentation slides, and you can go to those and just look at the white line on the presentation slides too. And all you need is a really inexpensive acrylic prism. I think Amazon sells those for under $10.
oh, okay. So basically, when we see different colors, they're just basically these three primary colors blending in different ways. So they don't. So basically, what you're saying is the other colors don't really have their own independent existence, but are merely just all kinds of, almost infinite combinations of just the three primary colors. Am I correct?
Exactly right. And the best evidence of that is if you look at a high definition television or a computer monitor or even your cell phone, and they only have red, green, and blue pixels, and yet it looks like they have a full range of colors. And biologically, when you look inside our eyes at our rods and cones, they only detect those three colors. And some people apparently have receptors for a slightly different shade of blue, or perhaps it's like the next ultraviolet color.
Wow.
Oh, we lost his voice.
Ken, you hot
Oh,
mic, or are you asking a question?
Oh no, wait,
Oh,
Liliana,
sorry.
can you hear him? Can you hear him?
Can you hear me?
Yep.
Yes, now I can hear you.
Okay, cool.
Good. Sorry, I'm not sure exactly what happened, but biologically, our eyes have receptors. We all have, discounting colorblind people, we all have receptors for red, green, and blue. Some of us apparently have receptors for the first ultraviolet color. I personally believe dogs have red, green, blue, ultraviolet, and infrared sensors. Because I notice my dogs are all the time barking in pitch black at things I can't see, but they apparently clearly see them. And they also spot the ultraviolet signature where another dog has peed on a plant or something, that I don't usually see unless I get really good ultraviolet sunlight beaming on it. and they seem to see those colors easily. A lot of research has been done claiming that dogs see only yellow and blue, but I think those experiments failed to take into account that that might have been skewed by not accounting for the fact that they could also see infrared and ultraviolet.
Yeah, it makes sense because I think they also hear more of this sound spectrum than we do. So it totally makes sense that they might even see more of the visible spectrum than we can see. So
Yes,
this
I
is really
would way up.
fascinating with the three colors because it's kind of it supports what I'm researching on my own also with some other, ancient text cosmologies. Thank you so much, Doctor. This was really beautiful.
You're
I got a
welcome.
question.
I live way out in the country where it's really quiet out here, and my prior female dog, she unfortunately passed a couple years ago, but she was really fake. She was freaked out by gunshots in the distance, and I could barely hear them, and I have really good hearing, but they would freak her out. So it's I think not only is their vision and their hearing good, but practically everybody knows their smell is also far superior to us. It's claimed they can tell the difference between compounds whose molecules are different by only one single atom. And that's why bloodhounds are so good at tracking down scents, for example.
Can I ask you something about why you brought in this example? Like, what does this have to do with the ether? Is this you basically showing like an analogy of like how it could be broken apart?
This particular example is what actually got me thinking about quantum mechanics and what's wrong with quantum mechanics. And I think that led me to look closer at the ether. And it took me a long time to figure out those last two equations for the real quantum levels and the real quantum wavelengths and the real quantum energy levels. But it all started with this, and I think it was Remus Poradin who originally published this particular white line on a background and black line on a white background. Remus is from Australia, and I've done video chats with him a few times and talked to him until I finally came to realize that what is really going on with prisms is not refraction, but the panes are splitting in different directions. So green doesn't refract beyond its initial refraction as it enters the prism, and green and blue deflect in opposite directions from that. And that's also why I dwelled on all the evidence for the fact that green doesn't deflect at all, which you know by the magenta line, where green is missing from exactly where it never was on the black line. So it took me personally a while to realize what this all meant when you put everything together.
Yeah, I'm trying to understand what you're correlating. I'm just trying to understand why you brought up the prisms in the first place.
Well, it all has to do with the quantum levels. And that's when I began realizing that these, let me see, where's the slide where I talked about this? On one, I think I didn't give any more information, but on one of these slides, I made the comment that all of this mixing happens at the Bohr radius. And the reason it's happening at the Bohr radius is that is the only radius in the atom where the period of the electron in orbit is identical to the period of the 45.5634 nanometer ultraviolet light. And so that's where all of the quantum mixing occurs. And then it occurs according to this equation, or if you prefer to work in energy according to this equation. But it's all based on mixing that occurs at the quantum level. And that's what got me looking at all of these things that ultimately led to me asking, well, could ether exist? And that's when I went back to the speed of sound equation and started calculating it. And once I figured out what the density and pressure were, then I started applying it that to other things I already knew about and realized that explains every physical constant that NIST publishes values for. And that's what led me to start comparing my values to their values, like in wherever those tables were. I can't find them easily scrolling through them this way, but
No worries.
Doctor, I do have one more
I'm going
question.
so fast, I'm
Okay.
losing myself. There we go.
Sorry.
I finally found the slide, but go ahead, ask your question.
Was this?
I'm just wondering, would you say that it would be correct to think of ether as being sort of the vehicle that maybe transfers temperatures like heat and cold?
Yes, I think that's definitely true. And I based that, I didn't mention that anywhere in my presentation, but if you go snooping around like on my author page, you'll find that I invented US patent 5,113,832, which is a method for air density compensation of internal combustion engines. And that patent resulted from, I have a background in electrical engineering and computer science. And I worked for I got hired by a fuel injection company whose electrical engineers were saying the software engineers were botching the engine controller, and the software engineers were saying the electrical engineers were botching the circuitry. And since I understood both electronics and software, they hired me to figure out which of them was wrong. And that's when I discovered neither of them were wrong. It was a Society of Automotive Engineers. Their density compensation was wrong. And it was wrong because it violated the laws of physics, and it violated the laws of physics because it didn't take heat transfer into account that it was occurring in the pressure and density of the air that was being sucked in. And so I think that same temperature transfer applies to the ether just as well.
Wow, that's such a that's such a great answer, actually.
That is a really interesting origin. You said there was their density compensations
Right, air
that were
density
wrong?
compensation. Yep,
Wow.
the Society of Automotive Engineers. So I immediately got ridiculed for saying that. They said, "Well, what makes you think the entire Society of Automotive Engineers is wrong?" And you're right. And when I answered that question, that's what led to the patent. And the answer was heat transfer.
Wow. Hence why Liliana asked that question too. Do you think the ether is like a vehicle for transferring heat and cold? Yeah, I could see that.
I'm
So-
positive it is.
This slide here, so I don't know what Hartree energy is, and I don't know what NIST is. Could you fill me in real quick before I guess further?
Yep, no problem. NIST is the National Institute of Standards and Technology.
Okay.
And they focus on extreme accuracy of physical constants. And so the Hartree energy is one of those physical constants they give the value for. And the Hartree energy is the exact energy of an electron in orbit of the Bohr radius, at the Bohr radius of a hydrogen atom. And that little 48 in parentheses at the end of the NIST value, that's the uncertainty. So those green 60 are plus or minus 48. So it could be as low as 12, or it could be as high as 108 instead of 060.
And you did it three ways because it's what, Newton's law of gravitation and then Coulomb's constant, and what's the bottom?
Yeah.
Or did
I did it 3 ways because I discovered playing around with ether constants that all 3 of those ways explain the same thing, and they all explain it because when you reduce it to the actual relevant constants, it's the bottom equation, which is the gravitational parameter of a proton times the mass of electron divided by the Bohr radius that the electron's orbiting at.
Oh, is the bottom one the one that you came up with?
Yeah, the bottom one's the one I originally came up with, and I worked backwards from there.
Oh, that makes so much more sense from that perspective. Okay, get it. That's awesome.
A lot of things in this presentation, you could come to the false conclusion. I went from beginning to end, but I went in the order I did to make it easier to follow what I was doing. In reality, I kind of randomly discovered these things, and I put them in what seemed like logical order after the fact.
That's fair enough. Yeah, no, that's an awesome
Actually, I
slide.
don't know that it's a logical order necessarily, but it was easier to explain to an audience order.
And this certainly goes with the theme of the proportional rationality. Again, you have these ratios that you've identified that now broad across all spectrums. Now that's what you're proving here. Even though you started backwards, what it does is it shows that it spans the whole spectrum. Right? That's amazing.
Right. It ties into everything that we know about mass, energy, gravity, electricity, magnetism, and at the end, although it may seem slightly out of place, all that quantum mechanics is just to show that relativity got quantum mechanics wrong. What the ether is doing is something a little bit different than what relativists think it's doing.
He's saying that they're all proportionate ratios and that they're all related, so that the same ratio exists within all. That's amazing.
Right, they're all related to the density and pressure of the ether and the speed of light, and all of those in turn are actually different ways to view the momentum of ether particles, whatever those may be.
And the density and the pressure of the ether is what starts everything, because that's what determined the speed of light in the first place, back from the permittivity and the permeability, right where we started. Nice.
Exactly. And so wherever that equation is, this is one of my favorite equations. And initially I began thinking of everything as what would the air be doing? And then I deduced from that, well, the ether should be doing something similar. So what is it doing? And that's how I weeded out what didn't matter and focused on what did matter.
I think I need to buy your book.
Yes.
Hopefully I laid it out in a way that's easy to understand and interesting.
What was your patent number again?
It's 5,113,832.
Okay, thanks.
And it'll show I lived in Colorado Springs at the time. Now I live just outside Colorado Springs in Peyton.
Just like Tesla did.
Yep. That probably also explains my fondness for Tesla. As you'll see through the book, I reference Tesla a lot. I quickly came to the conclusion he was on to a lot of things that were being suppressed by the elite physicists of his generation.
Oh, we never talk about Tesla in here, right, guys?
Never matter.
All hail Einstein.
No, this is great. Thank you for your presentation. That was awesome.
Yeah, this is epic. I'm definitely gonna have to go back. Does anybody else have any questions?
No, you basically took everything out of my head and asked it. So
Nice.
well played.
Well, I'm happy to hear that. I was expecting more difficult questions, but a big thanks to Eric, who gave some really excellent recommendations for this slide presentation. And it's better for his advice and recommendations.
Isn't
Shout
it
out to
always?
Eric.
Yeah. Isn't it always better for Eric? Thank you, Eric.
Eric's the man.
Hey, I have a quick question. When are we going to get this doctor and Dr. Bennett in the same room?
Right now.
Happening right now.
Already happened.
You are
Been
experiencing
here
it
the whole
at this
time.
moment.
Okay. I didn't see Cassander. Sorry there, Dr. Bennett. Well, I'm curious what he thinks about this.
He did come in a little late, but
Maybe he was watching on YouTube.
maybe. Oh, he's adjusting his microphone. Give him a moment. There he is. Hello, Mr. Bennett.
Yeah, I was about an hour late, Dr. Mike. I should have put a note to myself. Yeah, so I got your 2 books, and I'm going to go over those. And I see that covered the optics, very interesting optics of the human eye, and the misinterpretation of what the color mixing algorithm is for our visual capability. I'm going to have to go back and look at the beginning of the slides, but I think we should get together at some time and see if there is a connection between what you've done and the outstanding work of Atsutaski, who's done similar work. I don't know if it covers the same ground as you, but it would be interesting to see, as we advance in our knowledge of ether, what theories we can adopt and which ones we can throw out. But already I can see that there's a lot of benefit in the work that you've done. And are you involved in any ongoing research now?
I'm not engaged in anything specific. I kind of engage in whatever I can find time for, or that I can think about as I'm feeding dogs and scooping up poop and things like that.
Oh, I don't think he was
I
here
usually
for
think
the
of
intro. Sorry, go ahead.
usually think of things in the shower. I don't know why. That's my source of inspiration, but I don't have a dog,
so
so
me,
I
I try
can't.
to.
It does.
I don't spend enough time in the shower, but it takes me about an hour and a half every morning and every evening to feed the rescue dogs here. And so that gives me 3 hours of thinking time. And then it seems like we have an unusual number of things that break, or the dogs break, and there's always a lot of poop to scoop and other things to do. So that just gives me a lot of time to think about weird things. Like one of the weird things, didn't dwell on this. I don't think I only briefly touched on this in any of my books. And I've actually written 3 books. The first one is non-science. It's just plain ramblings of an old man about prime number 17. And then that quickly led to the second book about the scientific method. And then that also quickly led to the third book about the luminiferous ether. But I wound up editing that book for about a year and a half before I published it, just to try to get things in the right order and the right wording and the right analogies and that kind of thing. But anyway, one of the things that always occurred to me, we have these cones and rods in our eyes and they're receptive to the different colors. But what that doesn't explain is, why do we see red, green, and blue? Why do we have the sensation we do of what red is, what green is, and what blue is? And it makes it makes a little bit of sense to me that we invent yellow to explain why we're seeing red and green simultaneously. But I always wonder, what is it in our brain that tells us that's yellow? So a lot of what we perceive is our own imagination, not actually related to our senses. Whatever may be causing that, and that's a philosophical debate. And computer science is an applied doctorate, like a medical doctor, not a theoretical doctor like a PhD. And I'm a doctor of computer science. I don't remember whether that came out or not.
Well, the capability of vision is really a deep mystery. If we really dive into it, we could ask, how does the optical system merge two images which are from eyes which are separated from in spatial distance, and therefore they have different views, slightly different views of the environment? And how does it merge that into a single picture and blur? And then, of course, some of the questions you asked about philosophy start to get into, where does the brain become the mind? Where do we have things that we cannot explain physically, but start to delve into immaterial, or you might call it spiritual world? One of the problems with modern science is that it doesn't seem to distinguish the brain from the mind, although there are things that you cannot explain that the optical system can do based on just the physical properties of matter. And maybe there's an ether answer buried in that somewhere, but that's for
So my
future research.
my gut instinct is we reside either above or below the ether, and I'm not sure which. And things like the fact that we see red as red, and green is green and blue is blue are one of those things, because I'm not sure that can be explained by anything physical. Obviously, we know we've got sensors in our eyes for all of that, but that doesn't explain why we perceive the colors we perceive.
Perhaps the ether is a boundary between material and the immaterial, which is a particular philosophical belief. And it goes back to the Greeks, who had the theory of hylomorphism, that there is their explanation of change, the let's see, the substantial form and the actual act, the form and substance. And the definition of them was that it was the ability to change into any measurable physical object. And if you take that as the definition of ether, then it basically says that's the basic substance that exists in the universe, but it cannot be measured because it itself is pure potential. It has the potential to change, but it itself not have a substance. I don't know if you're interested in philosophical investigation of ether,
I'm
or
interested in philosophical, but I'm not sure I'm qualified. So I think you're on to something important and big, and it's probably turtles all the way down.
well, everyone has a philosophy, doctor.
I was gonna say, who's philosophically qualified? Come on, everybody.
Yeah.
Uh,
So that's a fair point.
Was
So in
philosophy
my
means
in
that
my book, sorry,
philosophy means that
I
you have an idea about how the world works. That is, you have a worldview, which
okay.
allows you to
So
navigate
that
through the
being,
world and make decisions. Yeah, go ahead.
I'll agree with that. And that being the case, that's why the cover of my book is a fractal. Uh, c- um, Based on what you just said, my philosophy is that our entire existence is fractal geometry, and that's why I put so much in the book about fractals. In fact, in my
Self-generating
first book,
patterns.
well, it's patterns, it's order generated from chaos, and in fact, in my first book, I hypothesized that that's the explanation for how somebody can be predestined and yet also have free will. Because with a fractal, the um, order that was designed into the fractal occurs regardless of the random path it took to get there.
Predestination doesn't determine what will happen in the future. It's just that someone or something has a knowledge of what the future will be. You yourself have the capability of making a decision because that future is hidden from you, but may be known to someone else. That's,
So I
that's
would
what I
say
consider.
I would define things slightly differently, that our ability to take our own path is the free will part of it, whereas the predestination is the underlying fractal that said no matter what path we choose to take, we are predestined to arrive at a predetermined destination.
Hmm. So at the beginning, we're determined by a certain fractal pattern, and that continues to evolve through our life. Is that the idea?
Um, it's like all fractals, it continues to contribute to the predetermined order, um, even if we take random deviations from that. And I give some good examples in the book that I don't have a good way to give right here, but I think my favorite in the book about the luminiferous ether, I show the probabilities and coefficients for a fractal that produces the word chaos completely randomly. So every time you randomly generate this, it occurs um, by a different path in different locations. But in the end, you can always see the word chaos. And I give a lot of details in the coefficients for that particular fractal, point out which probability within the fractal is producing each letter. And for people who don't understand fractal geometry, it's a little hard to explain that concept. But the underlying aspect of fractals is that it's a pattern that can start anywhere. It can take any path to get where it's going. Those paths are all random. You don't know in advance what path it's going to take. You always know in the end exactly what pattern it's going to produce.
Where 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 can I find a resource on this that you've made? Sorry, you mentioned you had something written on it.
That's in the appendices of my Luminiferous Ether book.
Okay, and I is that I guess someone here has that.
I'll post it for you, bro.
Thank you.
A fractal can be defined mathematically by using an equation in which you take the solution of the equation and put it back into the original equation. which generates a new equation, and then it continues in that way ad infinitum.
I think if you look at the equation P equals rho times c squared, you might recognize that looks a little bit like a fractal.
Just
So
rho times.
one of the really famous fractals is the Mandelbrot set, and I discussed that a little bit in the appendices of the Luminiferous Aether book. But it's an incredibly simple equation. But as you zoom in on a Mandelbrot set, you'll see it takes it's a very, very intricate, detailed pattern that seemingly has no end.
Mm-hmm.
A few evenings ago, Beasticles and I were discussing, how much free will versus predestination, exists. And the only analogy I could come up with that made sense to me is that there is the predestination that is kind of like the threads in a fabric going in one direction, let's say from left to right. If you have a piece of fabric sitting on a table, for instance, so the threads in the weave of the fabric that are going from left to right is the predestination, and then the free will is the threads that are going from top to bottom, and so together they weave this fabric of reality. So free will is operating within the parameters of predestination. I don't know, it just sort of made sense to me because I'm always trying to make sense of our world.
Yeah.
I think that makes sense, but what makes a little more sense to me is something like the Sierpinski triangle, for example, being predestination. It's the pattern you know you're going to get, even though every point in that triangle occurs randomly and it takes off in a random direction from whatever point it started at, and you don't, no two Sierpinski triangles are the same, and yet the outcome is the same every time when you look at it from the aspect of it's a triangle made of smaller triangles made of smaller triangles.
There's definitely a philosophical discussion for sure about predestination and free will. That's for sure. I reconcile it with just because you don't know your future doesn't mean you don't have a choice in how it's determined, right? It's like
Right. Yep.
yeah, perfect example is if you can look in hindsight about like the outcomes of an event, right? Where you're like, oh my God, I can't believe that happened that way. If that didn't happen, then this wouldn't have happened, and then that wouldn't have happened. And you can look at your life retroactively and then see the predestined, coinciding events, right? But only in hindsight, because you're not God. You don't have omniscience. You don't know how your future is gonna pan out, which is where it that's where free will comes in, where you do have to make choices. So, but yeah, that's what we were talking about, me and Liliana.
And I would view it slightly differently. I would say the predestination is the Sierpinski triangle, and we are the points. And we have free will because we can start anywhere and we can go off in any direction we want to. But in the end, we'll all be part of that Sierpinski triangle. That's probably too crude of an analogy, but it's simple enough to explain.
No, yeah, I get it. You can relate it to a fractal for sure.
Oh, there's my dog. There's one of them.
How many dogs you have?
Two. I only have two hands, so I limit myself to two personal dogs. And then today we have 10 rescue dogs. That kind of fluctuates up and down. We have 16 kennels. So 16 is our theoretical maximum. But we've had as many as 21 by putting multiple dogs in kennels at various times. It usually happens when we get a mom and her pups.
And these are dogs that were abandoned.
About half of them are found stray, and the other half are owner surrenders. Sometimes that's because of a death in the family or loss of a job or some other catastrophe. So it's about half stray, half owner surrender.
Wow.
Real quick, does anyone have any
know-
more questions for Michael? For Dr. Mike? Alan, you got any questions or anything?
Nope. I think that about wraps up any questions I had.
For sure.
Well, thank you for being so kind and gentle with me on my first time. I tried to come up to speed by watching as many other presentations as I could, and so I'm real impressed by everything I've seen so far.
That's awesome. Yeah. Shane and Alan, Toby, they do a lot of good work. And Stone. A lot of good people.
Cool. Well, I'm going to wrap it up here. I'll be back in a minute or two. I'm going to do the outro.
For sure.
All right, lads and ladettes. Thanks for tuning in. Let's see what we got coming up for the rest of the week. Oh. Tomorrow is Thursday, Schooling the Globers with Witsit. So that'll be the season premiere of season 2. So definitely check that out. And then Thursday, we'll be doing research and reading night. Not sure yet what we'll be reading exactly, but we'll get into something there. And then, of course, Friday will be Flat Earth Fridays, episode 116, the big 116. And then on the following Tuesday, I'll be continuing an old series titled The History of Interferometry. And this will be more personalized breakdowns per experiment rather than going over an entire swath of, the history all at once. So it'll be focused on just the singular Michelson-Morley experiment, going over the apparatus, the measurements, the how, the why, the who, all the good stuff. So make sure you tune into that. It may be 117. Let me double check. There's no time. I'll take your word for it, Maria. If anyone gets it wrong, I'm blaming you. All right. See you guys Thursday.